Collaterals and reciprocal identities. So first of all, let's look at what is on the table. But before that, by the end of the lesson, you should be able to find the domain of sine and cosine. Sine and cosine is all real numbers. Then you should be able to also find domain of tangent and secant of all real numbers, except pi on 2 plus n plus pi n. That is in the general form, where n is an integer. The domain of you should be able to also find the domain of cosecant and cotangent of all real numbers except n pi, where n is an integer. Alright, and lastly, the reciprocal identities. That is all what we are going to do here. So, an angle with a terminal side on x-axis or the y-axis Example: we can have 0, we can have pi on 4, we can have pi on 2, we can have negative pi, we can have pi, etc. The values of these are -1, 0, 1, or undefined. How do we know that? Let's look at what is here. So we are going to pick values from 0, pi on 2, like the interval is what? 90 degrees. Alright, so let's use that as sine, cos, tan. That's all the trigonometric what? Functions. So take your calculators and input what I have done and verify if it is true. So sine 90, but please, it's whether you are in degree mode or what, a radian mode. So those working in radian mode should work in radian mode. Should work in what? Radian mode, alright? And you know how to be in radian mode. If R is on top, it means you are on radian mode on your calculator. If you see R on top, it means you are in radian mode. And that means that you are using the values here. And if D is on top, it means you are using the values here. That is the degree mode. So how do we do that? Shift mode. I'm using. So shift mode, and when you press on shift mode, you see 3 is degree and 4 is what? Rad. So that will help you to get to know where you are. Alright, so that is that. So these are going to give you undefined. Alright, so that is that for that. Good. So conclusion from the table. We can say 2 things. And the first one is that -1 less than or equal to sine theta less than or equal to 1. The secondly, we can say -1 equal to cos theta less than or equal to 1. So it satisfies this range of values. What the first one is saying is that the domain of sine and cosine of all real numbers, the domain of sine and cosine is of all real numbers, and also the domain of tangent and secant of all real numbers except pi over 2 plus pi n, where n is an integer. We have already established that. Alright, so thirdly, we say that the domain of cosecant and cotangent is all real numbers, of all real numbers except pi n, where n is an integer. In case you are writing, I'm coming back again with the conclusion. The first one is that the domain of sine and cosine is all real numbers. 2. The domain of tangent and secant is all real numbers except pi over 2 plus pi n, where n is an integer, telling the domain of cosecant and cotangent is all real numbers except pi n, where n is an integer. Alright, quickly, let's look at the reciprocal identities. Let's look at the reciprocal identities and we see what we are going to have in the next. Reciprocal angles rather. Angles. Reciprocal angles. So identities are equations. Identities are equations that are true for all values of the variable, for which all expressions are what? Defined. That is what identities what mean. So quickly, let's move on. Quickly, we know that. All right. Now one sine theta is going to be 1 over cosec theta. That is the reciprocal identity. Or if sine theta is equal to this, then cos theta, then cosec theta is going to be 1 over sine theta. Right. 2. If cos theta is equal to 1 over sec theta, then sec theta is going to be 1 over cos theta. Thirdly, if tan theta is equal to 1 over cos theta, then cos theta is going to be 1 over tan theta. Alright. Where tan can be equal to what? Negative. Where cos can be equal to negative. Where sine can be equal to what? Negative. In the same way for this side. Good. So examples. Let's look at this example. Find the functional value of find the functional value of A. Cos theta if sec theta is equal to 5 over 3. B. Sin theta if cosec theta is equal to negative 12 over 12. So I may do one so that you do the rest. Alright. Now we know that let's take it from here. I'm doing only the first one. So from this identity, we know that cos theta is equal to this, this is equal to this. So we are given cosec theta to be equal to this, and we have to find sine what? Sorry, we are given sec theta to be equal to this, and we have to find cos theta. So cos theta is going to be equal to 1 over sec theta, and sec theta is what? 5 over 3. Therefore, cos theta is going to be equal to 3 over 5. So that will be the final answer for that. Okay. Let's look. So continue with this one. Okay. Sines and ranges of function value. Sine and ranges for function values. All right. We are still under the basic concept of trigonometry. The basic concept of trigonometry. Sines and ranges of function values. Okay, so we have the quadrants. We have the sine theta. We have the cos theta. We have the tan theta. We have that of cot theta. We have sec theta. 1, 2, 3, 4, 5. The last we have cosec theta. Alright. So in the first quadrant, in the second quadrant, in the third quadrant, and in the fourth quadrant. Okay. So let's do something. So we have our this like this. We have the first quadrant, the second quadrant, the third quadrant, the fourth quadrant. Okay. So the first quadrant, I'm going to represent it by X, and here T, and here C. So what we are saying is that in the first quadrant, sine, cos, in fact, all the identities, they are all positive. But in the second quadrant, it's only sine. It's only sine and its reciprocal identity, which is what? Cosec. This and this is what? Positive, but the rest, they are all negative. In the third quadrant, we are saying that tan and its reciprocal identity, which is what? Cot. That is what? Positive. The rest is just negative. In the fourth quadrant, you'll be using this very well, so make sure you get it. Alright? This is just the basic. All that we are doing is just the basic. In the fourth quadrant, only cos and its reciprocal identity is positive. The rest is what? Negative. So simply, you don't need to choose this, okay? You just need this. The first quadrant, the second quadrant, third quadrant, and the fourth quadrant. A, S, T, C. Then we call something all. The A stands for all. The S stands for students. Alright? The T stands for take. Take. The C stands for car plus. So this is all students take calculus. All means that all the trigonometric functions are what? Positive. So all students take calculus. In the second quadrant, students as only sine is positive in only sine and its reciprocal identity is positive in the what? The second quadrant. In the third quadrant, only tan and its reciprocal identity cos is positive. In the fourth quadrant, cos and its reciprocal identity is positive. The rest is just negative. So just remember, all students take calculus. Alright? And once you know that all students take calculus, it's just simple because all means first quadrant, students second quadrant, take third quadrant, calculus fourth quadrant. So that is that. That is that for that. Very good. So, is there anything more? Alright, so let's look at ranges of trigonometric functions. The ranges of trigonometric functions. So we have looked at the signs. Let's go to the ranges. Let's look at the ranges. Ranges of trigonometric functions. Now, for any angle, theta, for any angle theta for which the indicated function exists. For which the indicated function exists. 1. Negative 1 less than or equal to. That is the range for sine theta. This is the range for sine theta. And that is for cos theta. That is that for cos theta. 2. For tan theta and cos theta can equal any real number. Tan theta and cos theta can be equal to any real number. Alright, okay, so don't forget that. We are still under the basic of trigonometric functions, okay? And the whole course. Sec. So this is for sine and cos. This is for tan and cos. This is for sec. Sec theta is less than or equal to -1. Or sec theta is greater than 1. And lastly, cosec. Let me bring that here. Cosec theta is also less than or equal to -1. Less than or equal to -1. Okay. Or cosec theta is greater than or equal to 1. That is the range for that. Now take note that sec theta and cosec theta are never between -1 and 1. Take note that sec theta and cosec theta. Sec theta, let me write for you. Sec theta and cosec and cosec theta. This and this, they are never between -1 and 1. Do you know why? Do you see that sine theta and cos theta is between the same range? So some may be thinking that if reciprocal identity is also the same thing, but here it don't work like that. Alright. So alright, so let's try our hands on this one and what we have just discussed. Decide. All students get that. I like this. So now let's try our hands on this. Decide. Decide whether each statement is possible or impossible. Possible or impossible. 1. Sine theta is equal to square root of 8. 2. Tan theta is equal to 110.47. 3. Sec theta is equal to 0.6. Decide whether this is possible or not possible, and what we have just done. Alright, so looking at this, we know that sine theta so you can see that alright, I want to satisfy something. You can see that square root of 8 gives 2.8 something, alright. And is that going to be possible under the range of sine theta? This is purely impossible. This is purely impossible because that gives 2.8 something, so it's impossible. So first one is impossible. 2 tan theta 110.47. Now let's go back and check the range for tan theta. You are saying that tan theta and cos theta can be equal to any real number. So no matter what the number is, so this is possible. 3. Oh, sec theta 0.6. But we are saying that sec theta is whether less than or equal to -1 or greater than or equal to what? 1. But looking at 0.6 is we are saying that the thing can be less than or equal to -1 and greater than or equal to 1. So looking at 0.6, it seems it's between this. So this is what? Impossible. This is just impossible. Alright? Good. So that is all I have for you in this video. And wow, we are moving on. So in our next video, we are going to look at Pythagorean identities and quotient identities. Until then, trust that you revise on what I have just said, that we are going to do Pythagorean identities and quotient identities. So watch out for our next video. Bye bye.